Okay. 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 Oh, so today we will briefly review what is the computer vision, and uh, we will introduce how to use the OpenCV library. It's very easy to use. Okay. So I think this lecture will be finished within maybe 30 minutes. Okay. So what is computer vision? Computer vision is making the PC, the computer, to understand uh, the scenes. Okay, scene, SCENE, the scene. We are making algorithms to make a computer to understand scene. Okay, just like human eyes make humans to understand their scene. Okay, that is computer vision. Okay, but computer taking the scene using the camera, right? So in that sense, computer vision, they process the images or videos taken by camera, right? In that sense, they are having some intersection with optics and image processing or graphics, okay? And we are normally implementing computer vision algorithms in the form of code, in the form of software, right? So in that sense, it has this computer vision field have some intersection with traditional computer science courses like algorithm and system architectures. Okay, and we humans are not having only visual sense, but have some ear, right, for listening, right? And so, I mean, there could be other signals other than the visual signal. So this computer vision is also have some relationships with other modalities like speech and natural languages. Okay, so having some intersection with this this type of field. Okay, and also this computer vision field can kind of make eyes for the robot, right? So it has some relationships with the robotics field, okay? And in the sense that most of the algorithms in computer vision are some recognizing something, okay, in probabilistic way. So it has some relationship with the machine learning. So most of the computer vision applications are formulated as the machine learning problems. Okay, so anyways, computer vision field have many intersections with other related fields. Okay, okay, okay. And what is deep learning? Maybe this is the sensational event. Maybe you become to have some interest after seeing this event, right? So the DeepMind, Google DeepMind, uh, actually that company is located in UK, London. And this company made some AlphaGo, which is the algorithm that can do Go, right? So, and they experimented this Go algorithm with humans, and this Sedo Lee, which is Korean, who is Korean, compete with this algorithm, and actually this algorithm won 4 times, and this Sedo Lee just won once win the algorithm, right? So this guy is the best Go player, okay, best human Go player, but he cannot win more than once, okay? Anyway, this AlphaGo is using the deep learning algorithm for this Go algorithm, for implementing the Go game. After this event, people are more and more interested in the deep learning algorithms. Okay, this is happened in 2016. Okay, but in deep learning researchers, the researchers are interested in this kind of deep learning algorithm more earlier than this. So this was the year of 2016, but maybe this ImageNet is the largest data set at that time for image classification task. So what is image classification task is, given images, we humans label these images with 1,000 object classes, okay? So for example, this image is belonging to a container ship, right? And this image is belonging to leopard, right? So this is the labels humans are made, okay? And this is the prediction the computer made, okay? So, and this is the probability predicted from the algorithm, right? So, yeah. This is the good case. So algorithm predict this image is having some might, okay? And the ground truth class is might. So this is correct, right? So this is the image classification task, okay? In image classification, each image is assumed to have just one object, one main object. And the algorithm, their goal is to predict the correct main object, okay? Among 1,000 classes, okay? And there are lots of images in this data set. And this is kind of the sensational event that made computer vision researchers to be interested in the deep learning, okay? This is the year. The x-axis is showing the year 2010, 2011, 2012, and so on. And this is the error rate, okay? Error rate. This is not accuracy. So this is the opposite concept to the accuracy. So this is 100 minus accuracy. So in the year of 2010, the best algorithm that wins this ImageNet challenge. This ImageNet challenge is the image classification challenge using this ImageNet dataset, okay? In the year of 2010, the best algorithm which won this ImageNet challenge recorded 28% error rate. So in opposite concept, their accuracy was 72%, okay? When there are 100 images are given, 27 would be correct, but 28 would be wrong, okay? That's the meaning of this graph, right? Everyone following this? Okay. And in the year of 2011, the error rate was 25, okay? It means the accuracy would be around 75%, okay? But here you can see shallow, the word of shallow, okay? So it means it is not deep, okay? So before 2012, the winning algorithms for this ImageNet challenge was shallow learning algorithms, such as SVM, support vector machine. But in the year of 2012, you can see there are 8 layers. Okay, so shallow, these algorithms are having just 1 layer. So in that sense, they are called as shallow learning algorithm. But in the year of 2012, the best performed algorithm for this challenge was having 8 layers, which is deep. Okay, and the performance was a lot better than previous state of the art. Okay, and at this moment, the researchers are feeling that the 1% or 2 or 3% gain would be maximum after this. Okay, they think their accuracy is almost saturated, so there would be no further big improvement. Okay, after this year, but when this AlexNet, which is the first deep learning architecture, was introduced, there are huge gain in accuracy, right? Their error rate was 10% improved, okay? So this is very important event in computer vision society, okay? And after that, this computer vision field is completely becoming different. Everyone is using the deep learning algorithm instead of the shallow learning algorithm, okay? After this, in every year, the best performed algorithms are anymore not the shallow learning algorithm, but having more than 8 layers. 8-layer algorithm and 19-layer algorithm, 22-layer algorithm, and 152-layered algorithm, and so on. So these are very famous. Maybe you are already familiar with this deep learning architecture. This algorithm is called as VGG network, and this algorithm is called as Google LearnNet algorithm architecture, and also this is the ResNet architecture, and so on. Okay. So anyways, in the year of 2016, the AlphaGo appeared. But before that, 4 years ago, this 2012, this AlexNet appeared, and many computer vision researchers are surprised because it gives us 10% accuracy gain suddenly. Okay. And also, the next important event in this slide is this ResNet. Okay, the rightmost of this graph, this is the human evaluation performance. Okay, given 100 images, even humans predict wrongly for 5 images. Okay, so this is even humans can make some mistake, right? So given 100 image, 5 images would be wrong. But this ResNet, in the image classification task, it surpasses the ability of the humans, okay? So this is another important event in this graph, okay? So yeah, this is the deep learning algorithm. So we are making the layers of the architecture, algorithms architecture, by stacking some layers, making it deep. So they are called as deep learning algorithms, okay? And as we stack more layers, the performance is getting better and better, okay? So that is the trend, okay? And next, I want to introduce you some applications in computer vision domain, okay? So The first one is there are three main applications in computer vision domain. The first is image classification. So ImageNet is the data set which is dealing with image classification task. Okay. This is another data set which is dealing with image classification task, which is called as CIFA-10 data set. In this data set, it has 10 classes, airplane, automobile, and so on. And each image is having just one main object within it. And the task of image classification is to classify each image based on its main object. Okay. That is the image classification task. Okay. So are you guys following this? Okay. The next important application in computer vision is object detection task. Okay. I want to mention that in this image classification, it is not dealing with real-world problems. I mean, in the real-world images, images are not composed of just one object. Okay, but in this image classification, they are assuming that each image is composed of just one main object. Okay, that is the limitation. So in object detection task, they are assuming that one image is composed of multiple objects. Okay, and because of that, they have to localize object within image, and also have to figure out each image's object needs. Okay, so for example, here car is here, and so they first localize this region, and then recognize what is the object within this box. Okay, so here the answer is there. So car object with this amount of probability. Okay, so there are multiple persons, so they detect multiple bounding boxes, and they figure out these boxes are having persons. Okay, this is object detection task, right? But even in object detection task, there's some limitation. Okay, so for example, in this pink box, we are indicating that this box is car box, but some of the pixels in this box is not having car pixels. Okay, so next, most challenging scenario, most challenging task is semantic segmentation task. Okay, so in this task, we have to localize each object. And previously in object detection, we localize it using some box, but here we pixel wisely figure out which pixel is belonging to the object. Okay, and also we have to figure out which objects are there in this group, pixel groups. Okay, this is the semantic segmentation task. Okay, so this was three main tasks in computer vision field. But nowadays, people are more and more doing some more applications, like figuring out some skeletons or landmarks of the human body, hand, or face. And also even they are reconstructing some 3D meshes for these input images. Okay, and also even they are making new images. They are making the algorithms to draw some new images by manipulating some images attributes. For example, this is the original image, but we can change it to converting some expressions of these original image persons. Okay, to have some sad expression or happy expression or disgust expression, or for young female brown-haired woman, we can we can transform her hair color, or even we can transform her gender to male, or we can also transform her age. Okay, so we can enforce our deep learning algorithm to achieve this kind of drawing figures as well. Okay, so nowadays computer vision applications are more expanded, but previously these three tasks were made. Okay? And the next is I want to introduce how to use the Google Colab. Okay, maybe for some of you this might be very easy, but for some I think this would be new. Okay, so I will explain for that beginners. So Google Colab, as I introduced, this is the free cloud service provided by Google. Okay, so you have to have Gmail address. Okay, you have to register for the Gmail. Okay, then if you go to this web link, you can directly type the Python code on the web interface and directly see the result. Okay. So for example, so I made this kind of Google Colab. Okay. So if you make this new notebook, there would be empty notebook will be appeared here. Okay. Okay. So you can add code here, and if you print something like if you type this code and execute it, it may take some time to connect to the server. Anyways, this Google Colab is providing you a very intuitive interface. So you can directly see their result here, right? So for using this interface, the thing you have to do is to have the Gmail address and type this website. Okay, that's the thing you have to do. Okay, so if you make new notebook and if you type Python code, then it will simply work. Okay, this is the Google Colab. And in Google Colab, you can use many open source libraries like OpenCV and PyTorch. Okay, so you can experiment those two libraries within this Google Colab environment. And now, from now on, we will learn about this OpenCV library, okay, using the Google Colab. So this Google OpenCV library is, sorry. This OpenCV library is open source computer vision library. Okay, it provides easy interface to code image processing. Okay, and also it is compatible with many languages like such as C, C++, Java, Python. Okay, but we are using Python, so we will only use this library in Python. Okay, and in Python you can just do import CV2. Okay, then you can use a variety of functions implemented in the OpenCV library. Okay, and maybe you have some image files or video files for this code written in here. In subsequent slides, you need some files and you can download them using this link, okay? So I want to say that if you want to read JPEG images, it may take you some effort. So have you tried read some image files by yourself without using any libraries? Have you tried that? Can you raise your hand if you tried before? Okay, was it easy? How did you do?
I think I had to read the oral flight, so it was very hard compared to.
Okay, so how about you? 한국말로 해도 됩니다. 쉬웠어요? 할만했어요. But I mean, you had to study the format of the JPEG, right? No? JPEG 포맷 공부해야 되지 않았나요? 뭐 열어봤나요? BMP? 무슨 확장자의 영상을 읽어봤죠? MP4? MP4도 뭔가 압축이 돼 있는 거면 어떻게 압축돼 있는지 공부를 해야 되잖아요. Have you studied that? 뭐 다음에 얘기합시다. So, I mean, you have to study. If you want to read the image files, if it is written, saved in the format of JPEG, then you have to study the format of the JPEG. And you have to do inverse process. You have to implement the inverse process what JPEG compress that images. Okay. So when you try to read just one image, implementing that code takes some effort. Okay. It will take you maybe few hours to few days to implement reading component, right? And if the format is becoming different, some people save the images in BMP or PNG or other formats, you have to study each format and do inverse process. You have to implement the inverse processes for each images, okay? But in OpenCV, you can just type import CV2, right? This is for importing the OpenCV library. And you can just call cv2.imread. Okay. And this is some path in the Google Colab. And this is the flag saying that you don't want to change the images. Okay. Unchanged flag. Okay. Then if you type this is also the OpenCV code. Then it reads the images saved in this JPEG file and save it in this array. And this code will visualize it like this. Okay. This is the OpenCV library. Okay. This is very easy, right? So in the OpenCV, they already implemented that kind of format, right? And you can just simply use those code. Okay. So this is very convenient. And also you can use some flags for transforming the images. So for example, this is the flags for reading the images in grayscale. Okay. So now if you read this image in grayscale, and then this array is having some grayscale image. Okay. So if you visualize this array, you can see some grayscale image, right? Any questions? No, okay, too easy. And also, this IMG, because you read images into this array, this IMG, you can see their dimensions, okay? IMG, if you type this IMG.shape, then you can see this. And actually, this is interchanged. This is the height, this is the width, and this is the number of channels. Okay, so RGB, the color images are having 3 channels: the R channel, G channel, blue channel. Okay, so color images are always having 3 channels. Okay, so this is the dimension of the image array, and also you can access the values contained in the array, just like you access the array, right, in programming language. So this is the bracket, and you can access the left topmost pixels by accessing this 0, 0, right? Then these 3 values, the RGB, but in OpenCV, this order is BGR. Okay, blue first, green next, and red last. Okay, I don't know why, but I mean, OpenCV developers decided the order of this, so they are using BGR anyways. And also you can just access the blue pixels for these locations like this, and then it will return this value. Okay, so you can access image pixels, their colors or dimensions of the array by this manner. Okay, so now in program, in the code, in your code, it's easy to read and easy to read the images. Okay, even though the images are in diverse formats, you can read, right? And okay, and also this is the grammar, Python grammar that selects every column and every row and select only the first channel. Okay, so this is visualizing the blue channels of the image. Okay, this is the code for reading image, and this code is showing the first channel, the blue channel of the image. Okay, easy, right? And also here I made some examples of the code, but you can see if you manipulate images using the Photoshop, everything you can do with Photoshop can be done in OpenCV. Roughly, you can think like that. Okay, so you can manipulate images just like you edit the images using your Photoshops, right? So you can draw some rectangles using this code, and also you can draw some polylines. You can define some dot, their coordinate here, and you can connect that positions, that point, to make some polylines like this. Okay, and you can specify their color and thickness and so on. Okay, and you can even draw ellipse or circle, and and you can put some text using put text function, right? And you can resize the image size, and you can block images. You can detect edges using just 1 line of code, okay? And you can also detect some corners. And this is the image matching algorithm, which is maybe the most difficult algorithms in image processing domain, but this can be implemented in few lines of code using the OpenCV library. Okay, so what image matching does is, given 2 images having one same object, you can match the pixels. Okay, this is hard problem in image processing domain, but nowadays OpenCV is already having those algorithms, so you can simply use them. Okay, so this is some examples I made for helping you to understand how much this OpenCV is convenient to use, right? And but I think this is more useful to you. So we learned how to read the images, right? But this slide is showing how to save the images. After manipulating images, you have to save that image, right? So you can use CV2 I am right, this function, when saving the images. So this is the path for the image to be saved. And this is the image array, right? Manipulated image array. By calling this simple function, you can save the files, okay, with manipulated images, okay. And also even you can read videos simply using the OpenCV library. So for reading the video, you have to make some video capture variable like this. And this will read the frames, read each frame into, read each image into this, each frame of the video into this IMG until when there is remained frame, okay? So while true, this means when the cap access the last frame, it will return false, okay? So it will start, okay? So whenever we call this cap.read, new frame will be saved into this IMG array, okay? And if it is the last frame, this return would be false, unless this would be true, okay? So with this simple code, you can read video from the first frame to last frame, okay? This is the video read example, okay? So OpenCV is quite simple, right? I mean, I will provide the the collab code to you. So, and also there is the files here. I mean, so in this link, there is some image files I used in this experiment. So you can, I think you can follow all the things, okay? So I will share this in the Blackboard, okay? Okay, any questions? No, okay. So this is almost time. So if you don't have any questions, then let's finish here, okay? And in Wednesday, we don't have class, so we can meet again next Monday, okay? And maybe, I don't know, but our classroom could be changed. Then I will notice it in the Blackboard, okay? Okay, thank you, see you.